Hi there, my name is Ron Rogers, and this presentation is titled British Airways Flight 38. Can you land and hold short of the first taxiway? No. Okay, I'm kidding there. It sure does look like a hold short issue, and that was a controversial issue for a while when I was an airline pilot many decades ago. But no, this is not a land and hold short. Actually, it is a example of some pretty amazing airmanship on the part of the crew, I must say. This was a 777 icing accident. And let's take a little closer look here. All right, this accident happened on January 17th, 2008. At this time, I had been a captain on the 777 for 5 years, and I was a line check airman. And this flight was from Beijing, China, to London Heathrow. I've flown into Beijing many times and London Heathrow many times, but not that route, of course. This is a British Airways route. But the interesting thing about this is when you fly over very cold regions of air, you always have to worry about the fuel freezing. And they had an issue with this. Everything was in parameters, so that's why this thing got kind of interesting and got our attention right away, because we do a fuel freezing check, and the mechanics will drain some fuel, they will do a test, and they will tell us what our freeze point is, and then we set a memo in our system that gives us a 10 degrees C warning on if we're getting cool. And if the fuel's getting too cool, we have to descend or we have to speed up, get a little more skin friction, and warm up the fuel out there in the tanks. Now, the interesting thing about this is they did a remarkable job flying this. They were coming down the ILS, and when they advanced power, the engines did not respond, and the autopilot, the auto throttles were actually advancing the power, and the engines weren't responding. They actually got down to 108 knots on final, which for a 777 is very slow. And just before the aircraft was to really get in trouble, the autopilot goes, "Hey, you guys got it." It clicks off and say it's up to you now. What's interesting is that the co-pilot took over flying. I would have thought that the captain would have gotten on the controls, but the co-pilot took over flying, and the captain retracted the flaps from 30 to 25, which gave him a little more lift, killed a little bit of drag, and they did an absolutely remarkable job here. They missed the approach lighting. They touched down in the grass. And unfortunately, a 777, that's not like my biplane. It's not a good grass airfield airplane. No, not at all. And they tore the landing gear off and pushed some of it up through the wing, collapsed the nose gear, and came to a stop. But they missed the structure there, which I think is pretty remarkable. And there were no fatalities. There were 152 people on board, 47 sustained injuries, one was serious, and the serious injury was interesting because when the landing gear came up through the fuselage, it impacted a gentleman setting in, I got the seat here, it's like, I'll find it here in just a second. But it impacted the near this person's seat and caused them a lot of injury. Now here is runway 27. They were coming into 27 left, and that is a typical approach. I've flown that many times. And in fact, after this accident, the aircraft was moved off to the side of the runway. They put a fence around it, but it was very visible when you came in to land. Now, the fuel pumps on the aircraft had evidence of damage due to cavitation, which meant that the fuel pumps on the engine were not getting fuel in sufficient pressure, and they were getting air bubbles, and it was causing damage to the pump. Now, British Airways uses the Rolls-Royce. They're, dedicated to their engine manufacturers over there. We typically have Pratt & Whitney's for the most part, our airlines, and General Electric engines. But part of the system is you use the fuel to actually cool the oil, and they had a fuel oil heat exchanger. Now this is a picture of the fuel oil heat exchanger on the Rolls-Royce Trent 800 engine. And they did some tests where they found that you could have an acceptable amount of water in the fuel, if there is such a thing. Of course, there's always contaminants. You can have 100 parts per million of water in the fuel. And if this freezes, it can form a bit of a slush. And on their fuel oil heat exchanger, the design of which I guess led to this problem, because we didn't have the same issue on the Pratt & Whitney's, but you could actually clog this filter, this heat exchanger. Now the way the heat exchanger would get clogged was the water in the fuel would form ice on the inlet tubes. Now, how they determine this, of course, the thing about ice in accidents like this, it melts. And so there's no evidence left behind, so you have to kind of make certain suppositions. So they did some tests, and they found that they could get the fuel to freeze to the sidewall. Now, when they were flying through this cold area, they had temperatures of minus 101 degrees Fahrenheit to minus 65, but the fuel never got below minus 34 degrees centigrade, minus 29 degrees Fahrenheit. So the fuel didn't get dangerously close to its freezing point, the fuel actually itself. And that's what we always considered, was that the fuel would freeze. We hadn't thought about the ice crystals in there. And what they think happened, what they were able to duplicate, was they think it adhered to the sidewall. And of course, they're coming in on an idle power descent. And they were roughly 2 miles from the end of the runway at 720 feet when the auto throttles commanded thrust, and the engines didn't respond. So the airplane starts to slow down. It's on the glide slope, and at 200 feet, it was doing roughly 124 miles per hour. The autopilot disconnected at 150 feet, and that's when the co-pilot took control, and the captain did the retraction of the flaps. And part of the problem that was pointed out in the accident investigation is Boeing, and of course it makes sense, you would tie the landing gear to major structure. Well, the landing gear was tied to the main spar of the wing. The only problem with that is the fuel tank is attached to the other side of the main spar of the wing. So when the landing gear structure was pushed up through the wing area, it came in contact with the passenger at 30F. So if you were ever on one of my flights, I guess you didn't want to sit in 30F because you would really feel the impact of my landings. But it came up, and that was the passenger that was injured. And here is a picture of, you can see that little squiggle down there in the blue line. That's where it impacted. It just got across the road. They did a real good job of missing a lot of people. And there's a picture of the airplane. Now, there's an interesting fact that came out in this. They, when they shut down the engines, they're doing an evacuation. So you go through the procedures, and you shut systems down. And one thing they found, that they pulled the fire handle first, and then they shut off the fuel shutoff valve. Well, because of the design of the system, when they pulled the fire handle, they took all power away from the shutoff valves for the fuel that were in the wing spar area. If they would have done it in the other sequence where the fuel shutoff comes off first and then the fire handle, and that's kind of the order that you do it. You pull the throttle back, you got the fuel shutoff ladder handle there, the little knob, and then you pull the fire handle. Now, in the olden airplanes like the 727, it's a mechanical linkage, and when you pull that shutoff lever to cut off, you actually shut off fuel at the engine. But of course, what you want to do with the fire handle is electrically shut off fuel in the pylon area next to it. Well, what had happened is because they had pulled the fire handle and disabled the power, the valves never closed, and the fuel leaked out through this opening onto the ground. Well, that wasn't the only problem. Obviously, that would be a very small leak. They dumped 15,000 pounds of fuel on the ground, and what's amazing is dumping 15,000 pounds of fuel due to the structure being damaged and the tanks being breached. It's amazing they didn't catch fire. And of course, if they had caught fire, this had been a much worse situation. And there's a picture of the aircraft on the ground, the slides deployed, and of course you wouldn't really be sliding down that slide very well. You'd be more running down the slide. And a couple other pictures. And there's a picture taken from behind the fence, and they had put a fence around it. They had gotten cranes and moved this. I'll show you that picture in just a second. There's another one with the aircraft. Although the nose gear had collapsed, setting on the engines there, and oh gosh, that looks terrible on the engines. Setting on the engines, the front had just a little more slope on the slides. Another view there. And again, here's the touchdown on the dirt. Still absolutely amazing that they were able to miss a lot of the structure and slide up to the runway. And there's, you can see the right main gear there separated. It would have been farther behind. This is where they pulled the wreckage up farther forward. And there's a picture of using the cranes to lift the airplane. This was the first hull loss of a 777, by the way. Although the fuselage looks reasonably intact, it was sufficiently structurally damaged that the aircraft was not repairable, so it was scrapped. First hull loss of a 777. So anyway, I hope you found that interesting and informative. Thanks for watching.